Now, looking through this list of properties of matrix multiplication, there's actually one property that we use a whole lot with multiplication of real numbers that's not included in this list of properties for matrix multiplication. That is the property of commutativity. Okay? Commutativity is the property that doesn't matter which entry comes first. So that is 3 times 2 is the same as 2 times 3. When we're multiplying real numbers, we have commutativity. It doesn't matter if I write it as 3 times 2 or 2 times 3, it's the same thing. It turns out that we do not have this property with matrix multiplication. Matrix multiplication is in general not commutative. Okay, we saw a little bit of that when we were discussing the identity matrix. We saw that if I take a matrix A, a 2 by 3 matrix A, and I multiply it by the 3 by 3 identity matrix, I get one result, right? But if I swap it around, so now I'm left multiplying matrix A by the 3 by 3 identity matrix I3, this is not defined. All right, so just looking at that, matrix multiplication isn't defined. But it actually gets worse than that. Okay, even when the matrix multiplication is defined in both directions, it does not necessarily mean that the products in both directions will be the same. So let's consider a simple example. Let's let A be 0, -3, -4, -1. And let's let B be -3, 4, -1, -1. Now these are both square matrices. They're both 2 by 2 matrices. And so I can find product AB and I can find BA. Both of these will be defined. So let's find AB first. Okay, first row, first column, I get 3. If I take the dot product there. First row, second column, I get 3 again. Second row, first column, I get 12 plus 1, that's 13. Second row, second column, I get -16 plus 1, that's -15. All right? Now, let's find the matrix product B times A. So matrix B is -3, 4, -1, -1. Matrix A is 0, -3, -4, -1. So let's do the matrix multiplication. So dot product of the first row of the first matrix with the first column of the second matrix, so if I take the dot product of these two, I will get -16. And even with that, just that first entry, we could see we're not getting the same thing, right? Let's finish it off though. First row by second column, I get 9 minus 4, that's 5. Second row, first column, I get 4. Second row, second column, I get 3 plus 1, that's 4. Okay, so in this case, AB and BA are both defined. We can find what the matrix product is, but they are not equal. Generally, matrix multiplication is not commutative. Be a little bit careful. That doesn't mean it's never commutative. It doesn't mean if I multiply A and B, it never equals B times A. It can happen in rare instances. Okay, for example, if I take the identity matrix times any, in this case, 2 by 2 matrix, if I swap the order, because it's the identity matrix, it's going to give me the same thing. Okay, so it can happen sometimes that matrix multiplication is commutative, but it isn't a general property like it is with multiplication with real numbers. Generally, unless you are dealing with very specific matrices or have information that says so, generally you cannot assume that A times B, matrix A times matrix B, is equal to matrix B times matrix A.